All right, so I think we're gonna get started here. So thank you for coming. Welcome to the nRF9160 webinar with Nordic Semiconductor. We've got Martin Leeson joining us today to give an overview of the nRF9160 system in package and how it can be used in your low power cellular applications. Martin is an application engineer. He's working in the technical support group at Nordic Semiconductor ASA and supports customers with their projects based on Nordic's NRF products. Martin has dedicated the last 3 years focusing on the nRF91 series and cellular IoT in general to give the best possible support on Nordic's support portal DevZone. Martin today, he's going to begin with a presentation followed by a 10 to 15 minute Q&A session. We also have Carl Fawcett from Nordic here as well, and will be helping to answer questions throughout the event. So you might see him answering some questions there too. So if you do have any questions, there's a Q&A section at the very bottom of your screen. So you can use that to ask questions. We ask you to use that instead of the chat, just because your questions can get kind of lost in the chat if you don't use the Q&A. So the other thing that we're going to be having today is Martin's going to be working on some polls. So he's going to be presenting some polls throughout the presentation. So you'll get an opportunity to participate in those as well. So we'll have polls and Q&A at the very end. Thank you again for joining us today. And I'm going to let Martin take it from here.
Thank you, Katie. So yeah, let's start then. So my name is Martin. I've been working 3 years now in Nordic as an application engineer in tech support. I have a bachelor degree in automation and a Master of Science degree in electronics from the Norwegian University of Science and Technology here in Trondheim. So I also work in the main office here in Trondheim. So yeah, like Katie said, there will be some live polls. Let's just try to launch a poll so you can see how that goes. If you have any questions after this presentation, please use our support portal, DevZone. We will send out some links at the end of the presentations to include those. But let's just test the poll now so you can see how that works out. So now there should be a poll that you can see and answer those questions. This is for me to get a rough overview of what your knowledge is about Nordic. Yeah, so it looks like almost half of you have no experience with Nordic products. So so I will start from there then. So great, thank you. It's good to see that some of you have some experience with nRF91 as well. That's good. So therefore, I would like to try to shoot out a second poll here. So since there's so few of you that know about nRF91, I would assume that you also may be not that familiar with cellular IoT in general. So yeah, so I think from this I can gather that we just start with the basics then. Thank you. So just first, a little bit of overview of what we're going to talk about in this webinar, or this presentation here. First, I'm going to talk about basics of LTE-M and NB-IoT. I don't have a point on that in this slide here, but after that, we're going to have an overview of the nRF9160, how to use the nRF9160 application processor, and also how you can use the device for low power and how you can optimize your design. Also going to talk about the latest features we have. We have the new generation of the nRF9160 with a lot of improvements that they may not know of. And also some improvements on the modem side as well. We're going to talk about that. Then we're going to showcase a short demo. It's a UDP sample. So the nRF9160 will send some UDP packets to a server and then go into this power saving mode. We're going to see the current measurements from this demo here to see actually how low we can go. And then at the end, we're going to talk a little bit about how you get started with the nRF9160, what you're going to do to get at a DK, etc. So yeah, a little bit about LTE-M and NB-IoT. It's open standard. It's a technology in the low power wide area network landscape. So compared to, for example, Sigfox, LoRa, they don't have typical standard, and also it's unlicensed, while the LTE-M and NB-IoT network technologies is low power, has higher throughput compared to the older cellular technologies like 2G and 3G that you may know of. So what's nice with LTE-M and NB-IoT, you already have the infrastructure, the base station around the world, and it's relatively easily to incorporate the LTE-M technology, etc. on those. It's future-proof, of course, and of course it has a very good scalability with millions of devices, so you wouldn't have an issue with several devices in field. And of course, you have the quality of service and security and reliability while using typical networks, cellular networks. And the difference between those technologies. One technology could be better to use for one application, and the other technology could be better for other application, because they have some difference in, for example, bandwidth. LTE-M has 1.4 megahertz, while NB-IoT has as low as 200 kilohertz. It's around there, and you can see that the max throughput for LTE-M is around 300 and 375 kilobits for downlink, while NB-IoT is around 30 and 60. So this means that for application that wants high throughput, it would be better to use LTE-M, of course, and also, but since you have this low bandwidth and with NB-IoT, it has a better range. You can see that we have about 15 kilometers, and this is from the base station. So you, of course, in cities and landscapes, you often have base station much closer than 15 kilometers. But one nice thing with NB-IoT that is very good is this: it has a higher penetration with regards to buildings, etc. So you can have static devices like a parking sensor underneath in the basement, for example, and it still would have a connection to the base station. So because of these differences, you have much shorter latency on the LTE-M technology, while in the NB-IoT technology, you have more latency. It could be milliseconds compared to seconds. LTE-M supports mobility. That means that you have a very good handover between the base station if you have a moving target, moving device connecting to each base station, while NB-IoT has limited support for this, so you have to reattach to the base stations, and this could be using more power, for example. So for asset tracking applications, LTE-M would be the better options with regards to this mobility support. Also, LTE-M has roaming support, while NB-IoT has a limited support for this. This means that you can go over to other countries and other networks much easily while you in LTE-M. For both technologies, you can expect long battery life. This is, of course, highly dependent of the application you're running. So we're going to talk about that in the presentation as well. And of course, the deployment density is very high in both technologies. So here's just some quick applications for suitable for cellular IoT. It's asset tracking, wearables, for example, product service, water metering, electricity, gas, typically devices that will stand still for a long period of time, not move. Maybe NB-IoT could be more suitable. Smart home, environmental monitoring, for example, checking the oxygen level or the pollution in traffic, for example. Predictive maintenance, have a sensor in an elevator that can go off an alarm if it needs some maintenance. Healthcare, and of course, smart city infrastructures. It's just some of the cellular IT applications. So what's the advantages of the nRF9160 in this cellular IoT world? So we had three main goals when we developed this product. It was low power, ease of use, and integration. And with low power, how we did this was that we built everything from scratch for low power. And we also integrated all the memories and used low leakage process features in our device. So everything is, almost everything is made by us to have this low power in mind. And ease of use, of course, the cellular world could be very complex and has been. And our mission was to make this easy for customers to just employ our product and get connected and do it as easy as possible. So we have enabled self-service for thousands of customers and hundreds of applications. So and then last thing, but not at least, is the integration part. We made the nRF9160 system in package as easy as possible to incorporate in your PCB. So we're going to look how easy it is actually in later slides here. So here it is, the nRF9160 system in package, it's called. So it's 16 millimeters by 10 by 1 millimeter. So it's very small. It has multiband LTE-M and NB-IoT modem inside with support for GPS as well. This is made by our Finland team, working several years on this modem here, and is very mature now with a lot of stability and new features as well. We're going to talk a little bit about that later on as well. And it has a separate ARM Cortex M33 MCU dedicated for application you would like to run on the device. So like I said, it has a small form factor, and it includes power management IC, also the RF front end, and also some passives and crystals you need in the system package. So it has ultra low power. With what we mean by that, it has around 2.7 microamps in power saving mode, and also average around 18 microamps at 81 seconds EDRX. So I'm going to also explain this EDRX and PSM mode and what this is and what you can use it for. And also it has multi-band support for global coverage, so you shouldn't have any issues with that with regards to support for the bands in the world. It's also a pre-certified system in package, so more details about our certifications. I'm not going to go through all those in this presentation, so please visit our homepage, nordicsemi.com. We have a separate page there for all the certification updates. So now, here we have a nice diagram of our 9160 system in package. And this is just to showcase what's inside of the system in package. So you can see that we have a separate application processor and also a separate modem side. So that's one of the benefits with this device. And you also have this power management IC, which handles and optimizes all the power that's going in the system package. It'll have also the RF front end and all the passives and crystals inside this device that's needed. And we have a 64 megahertz ARM Cortex M33 CPU just for the application processor. And also we have support for ARM Trust Zone, this to prevent over-the-air attacks, for example. We also have support for ARM CryptoCell 310 for application level security, for keys, etc. Can be used for. Also a separate, you have your dedicated 1 megabyte of flash, and also 256 kilobytes of RAM in this application area here. We also have support for the typical peripherals, SPI, UARTs, I2C, PDM, I2S, PWM, 12-bit ADC as well. And you also have 32 general purpose input outputs, yeah, that you can program and connect whatever sensors or other devices you want. So that's the application area. The modem area is released by us as a binary blob that you just run on the modem side. You cannot configure the modem code. That's just a black box for our customers, but this is for security purposes. When you connect to the cellular network, you have to be certified, and you cannot change important modem communication stuff in there. So in the modem, we have support for Cat M1, and that's another way of saying LTE-M, and also NB1, which is NB-IoT. So these are for the release 13. And nRF9160 is ready for the Cat NB1 and NB2 release 14, which has some improvements. Also GPS support. And also worldwide operation. So like I said earlier, it's built from scratch for low power. It's made by us in-house to make it as optimized as possible to low power. We have support for EDRX and power saving mode for power savings. And also we have all the IPv4, IPv6 stacks, TCP, UDP, TLS, DTLS support in the modem here. And also you just, we have this 50 ohm antenna pin interface that you just connect the system in package to. Also the UICC interface supports the regular SIM cards and also your eSIMs, embedded SIMs. And this talks directly to the modem. So you don't have to handle that. That happens automatically with the modem. So here is just a hardware picture of how you can simply integrate this into your design. The only other things you need to integrate this is 4 capacitors, 3 resistors, LTE antenna matching, and maybe a GPS if you're going to use that. It's quite easy to integrate this to your PCB, or maybe you have already some devices in field that you want to connect to the internet, then it should be quite easy to integrate this. So what's the benefits to have this separate application processor and modem inside the nRF9160? So it's, you have seamless integration between these two. So you have dedicated resources on each core. The modem is abstracted for simple integration. Therefore you have efficient data and control transfers. And at the right-hand side here, you can see a little more detailed picture of how what's in the different blocks here. So in the modem, we can see we have the typical L1, L2, L3 stacks, LTE stacks, also all the IPv6 stacks, IPv4, TCP, UDP. And the way we can communicate with the modem from the application processor is using secure BSD socket APIs. To make this even easier, we have application layer of IP stacks with co-op MQTT HTTP support, LWM2M, which is lightweight machine to machine. And we have all our drivers and libraries that are available open source in our SDK to make your application possible to make as easy as possible. And on top, you have the user application, whatever you would like that to be, of course. Yeah, and this also means we can run an application that talks more or less directly to the modem. So people that are known with cellular devices from beforehand usually are known to this 80 commands way to communicate with the modem. So you can run something we have in our NCS, our SDK. It's an application, we call it Serial LTE Modem. You just run that on the application processor. So then you can use a host processor to send 80 commands via the UART, for example, or SPI, depends. Default it's UART. And then you can build it and use it as is, send 80 commands, set up MQTT client, connect, etc. just through 80 commands. You can also customize the Serial LTE Modem application to have your custom 80 commands, for example, that does whatever you want. And also Nordic can add 80 commands and features on request, of course. This is very great to use to just do some quick modem evaluation. If you get nRF9160 and just flash it, this application here, you can get up and running and test different things quite fast. So that's a very neat application we have. Here is a more detailed approach, way to show the difference between the modem and the application side and what's inside. So the whole thing we have called the nRF Connect SDK. So the modem itself, it's a binary blob view, which includes all the lower layer LTE, all the stacks you need, and also the API that you communicate with the application side. Also the SIM card talks directly to the modem. And for the application processor, we also have the NCS that has support for HTTP, LWM, MQTT, CoAP, and you run your application on this. You have support for device management, FOTA, that means firmware over the air updates. So you can update your application over the air, or maybe the modem firmware if you want to. So before I go next here, I want to try to give you a new poll. So the question is, what is the one parameter you value the most from a cellular product? Is it quality, robustness, ease of use, power consumption, cost, or size? If you had to choose one, what would it be? So it's great to see that most of you chose the power consumption now, because that suits my presentation. I'm going to talk about the low power. But another good thing is that all these parameters here are very good for the nRF9160. So to save power, what do you need? You need an optimized hardware and an optimized software. So our hardware is bottom up, built from scratch to have low power. You have low leakage processes, optimizing the radio performance as well. And also we strive to have optimized software so you can benefit from this low power and hardware we have. And another thing is that you need a smart application that takes advantage of our dual core, optimize the application. For example, when and what to send. It's quite costly with regards to power to turn on and off the modem each time you're going to send things, for example. And if you're going to send things very often, that's going to, of course, use a lot of power. However, we have some good solutions to get a low power, for example, PSM mode with regards to this. And also to get a low power device, you have to test. It's important to test on live networks. Some networks have other parameters or grants you different numbers than other networks, for example. So some things are restricted by this. We're going to talk about that later on as well. Of course, with regards to testing, Nordic is more than helpful to answer your questions and support you on DevZone, or give you a free schematic review, hardware review of your designs to help you out get your low power devices. So now a little bit the basics of the different modes the modem can be in. You have RRC, radio resource control connected mode. You have RRC idle mode, and power saving mode. So you have these 3 steps: RC connected mode, you transfer your user data. And this is using the highest power. You are synchronized with the network. And when you don't have anything to send, it will automatically go in RC idle or PSM mode, dependent on what you have configured. And in idle mode, you can sleep for short intervals to save power. You can use a technique that's called extended DRX, which can help you sleep between the paging time windows to check if there's some things from the network that you want to receive, or you should wake up the device, for example. This gives you a shorter downlink latency compared to power saving mode, which is the mode you use to sleep for a long time. For example, if you're going to sleep 20 minutes, several days, you use this mode. Then you have longer downlink latency because the network can't reach you if you want to reach the device. However, you can wake up from from RC idle or PSM mode when you want. If you have an alarm on the device, whatever, you can wake up from this mode and go directly to connected mode. So here is a little bit more detailed about the connected and RC idle mode. Let me see if I can spotlight. So in here you see the current, and here you see the time. So first we have a block of showing the network sync. You sync with the network, you set up the radio source control, and then you send your data. When you don't have anything to send, you will go, the network has an RC inactivity timer. This is different from network to network. Some networks can have a couple of seconds, while some networks can have minutes. So this is important to test out and check out. In between those areas, you have something we call CDRX, connected DRX. And these are short intervals you can see here to see if there are something. And you don't have anything more to send, or the network doesn't have anything to send to you, you go to this RC release and you go directly to RC idle mode. Here you can have the EDRX interval. When you talk about EDRX, we usually refer to this area in the RC idle mode. So here we can, for example, request from the network up to 44 minutes of EDRX intervals. So here you can, the device sleeps, listening and check if the network has something to send. If not, it sleeps again and then goes on. And then you save a lot of power doing this. Like I said earlier, you can wake up at any time. And then some networks can even store some data for the device. So, of course, longer intervals gives you a lower power consumption. And now the PSM mode. So in this figure here, we showcase almost the same thing without the idle mode. We have the connected mode here. We sync up. So you turn on the device, the modem sync up with the network, and also use SIM card, set up the RC, sends the tracking area update, send your data, and then goes to this inactivity timer because it hasn't anything more to do, and gets released from the network, and you go directly to this power saving mode. This is can in theory be from 10 minutes up to 413 days. While this is different from network to network, of course, how much delay they would grant. And this is very good to save power for a long period of time. So this is just for the modem here. So you can make the modem sleep while the application processor works, get sensor data, etc. And now a little bit about sending data from the device. So people should know that sending over the radio, it costs a lot of energy and also some subscription fee depending on the carriers you are running through. So it's important to try as best as possible to send information and not data. For example, do not send all the accelerometer data from a sensor from a device that's flipping around, but instead send the information, all the processing data is happening in the application processor, for example, and the device flips over sideways. And now this is a package, for example, that's very important. It's the right side up, and if it's flipped over, it sends an alarm. Okay, now it's flipped, and you send the data and send the information about this event. And you can also, of course, send when anything interesting happens, an alarm or that kind of stuff. So those pictures I showed you are from our online power profiler. So this is a very good tool that's located on DevZone, where you can simulate different scenarios, set up your network parameters to see how much power you may use for your application. So it gives you a good estimation of how much power your device can use in field. So this is complementary to one of our samples in NCS, our UDB sample. So you can use the same configurations as close as possible, at least. For example, send the PSM interval for 10 hours. You can just directly write this in the application and compare the simulated with the real data. So you should check that out at least. For my next things I'm going to talk about is our new generation of nRF9160. So the first generation has been out for about 1.5 years, I think, or 2 years, I can't remember. Either way, we have this second generation now, and also some modem firmware upgrades. If you're familiar with nRF9160 from beforehand, you will see this second generation has a lot of improvements, and a lot of these improvements is low power. So before we had around 4 microamps PSM floor, for example. Now we can achieve 2.7. This is because we have optimized our hardware. We also have a system off mode, which is around 1.4, where the MCU is off with the GPIO retention, modem is off, and you wake up device with GPIO. You don't have RAM retention in this. And also for RC idle mode, this is for LTE-M technology. We have improved our numbers there as well to 18 microamps here and 6 microamps for the EDRX intervals for 10 minutes, which a paging time window for 2.5 seconds. And here is some bragging numbers compared to other modules in the market. So our device here compared with the closest module with regards to the power saving power numbers, we can see that we have a 91% better than the closest module here, with the PSM floor around 2.7. And PSM event boot is around 105 millijoule. Also, these numbers I have already talked about. However, our nRF9160 has a low power application on board. None of these modules has that. They are just modems. So this is new, and also which also gives you a good improvement. And also we provide the SDK, of course. And There's also a lot of GPS sensitivity improvements and power enhancement with our latest modem firmware version. So before we had some poorer sensitivity. Now we have improved this a lot through modem firmware upgrades. And we all, like we said earlier, we always try to optimize our products as best as we can. Now we just updated our hardware, so we strive to update the firmware running on the device. So our newest modem firmware improves the GPS a lot. So if you have some experience using the GPS from before, now it's improved, so you should try to test it with our generation 2. You can also see that the power consumption has gone a lot down since our last firmware. And we also have some GPS improvements with regards to assisted GPS. So assisted GPS, usually we get almanac and ephemeris data from the satellites. So the GPS receiver is on, we download the almanac and ephemeris data, very low throughput. This can take a long time. GPS is on, GPS uses a lot of current, and then you can start to search for all the satellites and get a GPS fix. So this GPS, assistant GPS, instead of downloading those data from navigation data from satellites, it instead do this through our nRF Cloud, for example, platform, or another cloud platform. For example, we have also support for this SUPL library, which is used by cell phones, for example. So then you just turn on the modem, download the data very fast, and then you can just search, get a GPS fix around and under 5 seconds. I've seen sometimes as well, but you can expect 5 seconds in open sky areas compared to 36 seconds. So that's a lot of improvement, and this also will greatly improve the power consumption on the device, since you don't have to have the GPS on all the time. So all the data processing and is packed in nRF Cloud and sent directly to the device. So this also saves the data costs and power. So you can have normal assistance. So you save this ephemeris and almanac data. These are valid for 4 hours usually, but we will in the future have support for something we call predicted assistance. So you don't need to re-download these data until 7 to 14 days. This is typically very good for devices that you want to have as low power as possible, of course. And of course, we have a way to locate your device based on the base station you are connected to. This is maybe the lowest power possible way to find approximately where your device are. And this will, of course, not be accurate, but if you're only interested in where this device is in the world or in the country, in the city, you can do it through just a base station location. So now I'm going to do a live demo of the UDP sample. So I'm just going to switch here to Visual Studio Code. So here we can see the code. Here is the main. Yeah, okay, let's start here. Here we see the NCS folder. In our NRF, we have a lot of samples, both for the 53 series and nRF91 now. We have GPS here, but we are looking at the UDP sample. So here's the main file. It's quite a simple file that sends some data to a server and then goes to sleep. Right now, it's configured to not go in PSM mode. but it goes in idle mode instead and has a EDRX interval for about 20 seconds. So let's turn on the current measurements to see how this. So now I just restarted the device. Now we can see it connected to the network very fast, sends the data around here. So it just sends a UDP packet. And then we have this famous inactivity timer. So for this network, it's around 6 seconds. And here we have the first EDRX interval going on. It's around 10 seconds, so not 20. And in between here, we can see that the average current is 38. That's quite high. Why is that? That's because the SIM card is not turned off. So the SIM card is not in shutdown mode. It's called idle mode. So we can see that the SIM card is actually using a lot more current than the nRF9160 SIM itself. So how can we prevent this? If you have an EDRX interval longer than 10 minutes, the modem will automatically take care of this and shut down the SIM card. So now we just are in connected mode and idle mode with the EDRX intervals. So let us see what happens if we go from connected mode and directly to power saving mode. So now just turned off the EDRX support and enable the PSM intervals. Now I'm going to flash it to the device. So I have a DK now connected to my computer and also connected with the current setup to measure current. And this PSM interval is set to 10 hours. So it will sleep in 10 hours and then wake up and send data. Yes, so now it's flashed. Let us record and then restart the application. So again, we restart here. We do the network sync, attach to the network, send the data, and then we are still in connected mode in inactivity, RC inactivity timer for around 6 seconds, and then go directly to sleep. So I said that we have around 2.7 microamps floor current. And this is showcased up here. We can see the average is 2.57, so it's actually lower than in our specification. So this is quite good numbers we're seeing here. So imagine you have a device that sends some data, sensor data, water meter, for example, and sleeps for 1 hour with by only using an average current consumption for 2.7. So that's how you can easily incorporate and use the PSM mode. So now that was the quick demo. I'm not going to go through the NCS and everything here. It's we have separate webinars and videos and tutorials for this. So I recommend checking those out for more details. However, how do you get started with this incredible technology? Well, we have our development tools. We have development kits, nRF9160 development kits with out-of-the-box cloud connectivity support. You can connect to the cloud very easy by just getting started with the nRF9160 DK. We provide the nRF Connect SDK. We call it NCS for short. It includes a lot of samples and applications already. And we have the Zephyr real-time operating system running this, with including all the hardware libraries, etc. And it's open source. It's provided on GitHub. We also have a lot of software support on the desktop side with Getting Started Assistant and Toolchain Manager, which will help you download the SDK, get the environment set up quite fast and easy. We also have Bluetooth Low Energy, of course, applications on the desktop side, program application, and something called LTE Link Monitor, which is very good to use with the nRF9160 to, for example, read out network data and some modem information through 80 commands, for example. And we also have something called Trace Collector, which is very good for debugging with regards if you have some issues. We can get a modem trace taken from you guys with this application here. And also we have the nRF Connect for Cloud, of course, which is our cloud solution with examples, device management and SIM management. So you can connect your nRF9160 to this cloud service here. So we have two main kits. This development kit, which powered by USB, has support for expansion headers. It also includes an on-chip debugger with USB support connection, and also you also have this iBasis SIM card with 200 megabytes free data. And this other neat product we have is this Nordic Thingy 91. This is a prototyping product platform. It is battery powered. If you know about our Thingy 52, this is the Thingy 91. So it's just the same thing with the nRF9160 on board. However, this one also has a 52840 to be able for you to maybe use it as a gateway application if you want to, or but mainly it's just used as a board controller for the Thingy 91. And also you can have a modem and application programming over the USB here. It comes with iBasis SIM as well, and to 20 megabytes of data for free. Here is a little closer overview of the Thingy 91. On the right-hand side here, we can see it has a lot of sensors already on board. You have a buzzer, light sensor. You have almost every sensor you need to do some light prototyping. And also, it's an excellent starting point for prototyping your designs, checking out how it works, showcase to clients. And you also can see it has a small form factor. Here we see a little antenna, and this antenna supports both LTE-M, NB-IoT, and also GPS. So in this design, we have chosen to use one antenna by Fractus Antennas. So when you make a PCB or your design, we strongly encourage you to talk to antenna manufacturers, for example, Fractus Antenna, to help you out with the antenna design to fit your application. So all the hardware files, etc., is open on our web page, so you can just use that as reference for your application, for example. And we also have this nRF Connect SDK, which has the whole framework for your application. It's free, open source on GitHub. It's continuously upgraded and developed and improved. You have lifetime support. The 1.4 release was last week, I think. So we have a lot of new features. I think there's a webinar on this next week to showcase all the features for the short range and the cellular part for NCS 1.4. It integrates the Zephyr real-time operating system. And like I said earlier, it's on GitHub and uses version control management with Git. So you have the Zephyr kernel, all the Nordic low layer firmware included, and everything you need almost. So, and here's a long list of samples that's already in NCS now. So to highlight some of them, we have AVS IoT sample, support for Azure, Simple Cloud Client, nRF Co-op, MQTT Simple, lightweight machine-to-machine, HTTP application update to do some application updates through HTTP. Also support for modem firmware updates, of course. And the sample I showcased was this simple UDP sample here. So how to get started? You order a kit, either a Thingy 91 or the 9160 development kit. I would recommend maybe getting the 9160 development kit at the beginning. It depends what you want, but since it has this debugger on board, it makes it very easy to just flash and debug your application while testing. Then you create a user account on nRF Cloud, unpack your kit. In the Getting Started guide, this showcases a little more in detail. And then you get connected to this cloud account, and then you can configure and monitor your cellular device. And then you can, for example, download the nRF Connect for Desktop with the toolchain manager, which downloads all the toolchains you need with the Sega Embedded Studio IDE and compilers that you need to run NCS. So it also installs this nRF Connect SDK very easily. On Linux, you use the Getting Started assistance. So that was what I wanted to talk about. So let's have a Q&A session. So since we have some time left. So it's good to see that Carl has answered a lot of questions already. So let me see here. There is one question here. Where can we find documentation on how to set Visual Studio, Visual Code Studio to compile for NCS? So we don't have a separate blog for this. However, if you search on DevZone, you should find that. A step-by-step guide. However, it's very easy to set it up. You go to File, Open Folder, select the NCS folder to get these nice files and folders here. And then you just go to a new terminal and open a terminal. And then you can just build your applications through the terminal. So all this is how to use the terminal, etc. It's on DevZone if it's not already in our documentation on how to do this. But we have a very good NCS tutorial on DevZone. I think it's 3 parts. It goes into details about this. So go to DevZone and go to tutorials page, and you should go through those. Yes, and the next question. Are the sensors on the Thingy 52 and the Thingy 91 the same? So they are more or less the same. So they're not exactly the same manufacturers or whatever, I think, but it's all the details is in the product specification, of course, with regards to the sensors, but it should include all the sensors, more or less. I don't think it has a microphone, but it has a buzzer, the Thingy 91. Okay, so Spencer Pratt. What kind of certifications does this come with? Is it pre-certified for several countries, or would this be done for the final product? So this SIP is pre-certified for a lot of things. I didn't include this because I have a little slide here with some information about this. We are certified in GCF and also PT, CRB, CE, FCC, I said, and all these different carriers. So I wouldn't go in details about this because this list keeps growing each day almost. So the latest information can be found on our home page. So if you go to nordicsemi.com and then certifications, you come to this page, which includes all the certification for the nRF9160. So here we see the PCA certification. We have different carriers. And then we have the complete list of the bands certified in the world globally, and also regulatory with LTE-M and NB-IoT. Yeah, so yeah, there's a new question here. Can you give some clarity about a debugger on DK versus Thingy? As I am waiting for my Thingy, I had an impression that it doesn't require external J-Link. Unfortunately, the Thingy 91 does not have an onboard debugger. So, but you do not necessarily need an external J-Link, since we have support for this DFU support. So you can put the device in serial, I can't remember what it's called, but you can put the device in a special mode, then you can connect the program app and then just flash your application this way. It takes a little longer compared to using an external debugger to flash the device, but you should be able to flash your modem and also your application to the Thingy. One nice thing is that you can use the nRF9160 DK debugger to debug the Thingy actually. So the DK has a debug output port. So you just need a 10-pin connector, and then you can actually debug. So here you can see from the product spec, we have a debug port, debug out port here. So you just connect the debug out directly to the 10-pin input on the Thingy, and then you can just debug the Thingy through that. Yeah, serial DFU. That's thank you. Yeah, doesn't seem like we have any more questions. So maybe Katie, you want to take over?
Great.
I can just add one thing.
Oh, go ahead, Carl.
Yeah, I just there was a question regarding if we're giving away any kits. We're unfortunately not doing that today, but we're going to give kits away in an event next week with Electronica Virtual. I will add the link in the description, in the chat, then you can have a look there.
Thanks for that. That's excellent. Thank you so much, Martin, for coming on and giving such a great presentation. We really appreciate it. And thank you, everyone, for all of your great questions. We will be sending out an email later, either this week or early next week, with the link to the recording, as well as the slides and the Q&A, because I know there were a lot of great questions, and Carl answered a lot of those via text. So you guys can see all of those questions that came in and all the answers that Carl sent for those as well. So we appreciate everybody coming, and thanks Carl and Martin for all of your help today. Hope you have a great rest of your day.
Thank you.
You as well.
All right. Thanks,
Bye.
everyone.
Bye-bye.
Bye.